Today we're going to be learning how to divide polynomials. But before we can get to that, let's take a second and do a quick review of how to use generic rectangles to actually multiply polynomials. So let's say we wanted to multiply 3x minus 2 times 2x cubed minus x squared plus 3x minus 1. So essentially what we're doing here is we're saying let's do this times this. And in in Algebra 1, you could do a lot of this type of work. So what they're asking you to put in the box here is just what that product ends up being. And that product ends up being the sum of everything inside the box. So for instance, I see 6x to the fourth, and then I see two terms that each have an x cubed in them. So I would add those together, and I get minus 7x cubed. And then I see two terms that have a squared term. So I would add those together, and I get plus 11x squared. And then I see two terms that have just x terms, or two x terms. So I would add those together, I get minus 9x. And then finally, you can see, I'm trying to find a color I haven't used yet, just this 2, so plus 2. Now, what's interesting about this, and it might ask you this later on the in the Desmos, but kind of what I've done here, I've highlighted the terms that are alike. So these two boxes have like terms, and they give you this piece. These two boxes have like terms, and they give you this. These two boxes have like terms, and they give you this term in your polynomial, and then you've got this guy giving you the coefficient, and this guy giving you the leading term. So in order to use generic rectangles to multiply, it's pretty simple. The interesting thing here is that anything on the diagonal adds together to give you a term in your polynomial. And I like the fact that these are diagonal from each other. So the things that don't have something diagonal from them are the either the highest power or the lowest power. Okay. This is kind of just basically saying what we just said about noticing that the diagonals are the same power. And again, kind of repeating that again. So let's go ahead and let's start up level 1. Now you can work with each other. I'm going to kind of help you if you get stuck. So I'm assuming if you're watching this part of the video that you either want to check your answer, which it'll check it for you, or you just want some help getting started. As you're doing this, it's going to give you different colors for these boxes. So like this box, I don't know what colors it highlights it on your paper or in the Desmos activity. I feel like this one ends up being purple. I'll just put in whatever colors I want here. We'll do these are orange. And that tells you where the like terms are, right? So anything you see that has the same color ends up being a like term. We'll do these ones in pink. And then this last guy we'll just do in black. Okay. Now, what that means is that in order to figure out what goes in this purple box in our polynomial, we've got to know what goes in this purple box here. In order to know what goes in this orange part of our polynomial, I need to know what goes in those two parts there. So let's kind of zoom in here and do the work. So really, we're just multiplying again, right? So I multiply 2x times 4x cubed, and I get 8x to the fourth. Now I'm just going to go across that. Actually, I'm going to go down each column. So then I'm going to multiply 4x cubed times negative 3 to get negative 12x cubed. Then I'm going to go to the next column, and I'll have 2x times 6x squared gives me 12x cubed. Negative 3 times 6x squared is negative 18x squared. And then I go up to the top of the next row. I get 2x times negative 2x, which is negative 4x. I get negative 3 times negative 2x, which is positive 6x. Sorry, I missed a squared on this one. Then I go up to the next column, and I do negative 3 times, 2x times negative 5 is negative 10x. And then finally, negative 3 times negative 5 is positive 15. And then what I do with that, I fill in the boxes below by just looking at the corresponding colored boxes. So the very first term is just 8x to the fourth. That's the only x to the fourth term. And then I'm going to add these two together to get 0x cubed. And then I'll add these two together to get negative 22x squared. And then I'll add these two together to get negative 4x. And then I have my constant term of 15. So you should be able to put this into the boxes on Desmos. It's going to tell you whether you're right or wrong. If it says you're wrong, just double check that you don't have a power written incorrectly, or that you don't have a sign missing or something like that. Also, I recommend using Shift and then 6 to get your powers. For whatever reason, that seems to interact with the Desmos a little bit better. All right, so let's say you've gotten past level 1, you're now on level 2. So what you notice about level 2 is that you're given kind of pieces and parts of everything, but you have to fill in the missing parts. So this is a puzzle. It's what we're calling a polydoku. It's a polygon, or it's not a polygon, it's a polynomial Sudoku type of thing, right? So you got to figure out what is going to go where in order to make what's inside the generic rectangle and what's outside the generic rectangle true, and makes it all fit together. So the first thing you have to really think about, and this is a little bit of a hint if you look on the right hand side of your screen, is you have this as x. What would I have to multiply by x? So what would this have to be so that this times x gives me 2x to the fourth? And that's going to be what goes up top. So hopefully you recognize that's going to be 2x cubed. And now that you know what that is, you can fill in this first purple box, because now you know that this is 2x cubed and this is negative 4. Multiply those together and you get negative 8x cubed. Okay, so now we kind of look at some other things here. I know that this box is 12x squared, and I know that one side of it is negative 4. So this side has to be something times negative 4 that gives me 12x squared. So that can help me figure out what goes up top. And that's going to be negative 3x, because negative 3x, negative 3x squared, because negative 3x squared times negative 4 gives me positive 12x squared. Okay, so now that I know what this is, I can multiply it by x to get what's in my other purple box. So x times negative 3x squared is negative 3x cubed. Okay, I know the next row and column elements, right? I know this is negative 2x, so negative 2x times x is going to give me that orange box, and that's negative 2x squared. And then I know this is 2x. 2x times negative 4 is going to give me that first green box, so that's 8x. And now you might think we're kind of stuck. But remember, we know what's along the bottom, and along the bottom is what everything adds up to inside our box, right? So I know that this 2x to the fourth is going to go here. I also know that when I add my purple boxes together, I'm going to get negative 11x cubed. I know that when I add my orange boxes together, I'm going to get 10x squared. I know that when I add my green boxes together, now here's the key, I know I should get 12x, which means that this green box has to be 4x. And then I can fill in that missing dimension here, right? Because I know this is x, this has to be multiplied by x to get 4x. So I can figure out that this must be 4. And then as soon as I know that, I can multiply the 4 times the negative 4 to get my last term, and then that will help me fill in the bottom as well. So remember, what we're saying here is that x minus 4 times 2x cubed minus 3x squared minus 2x plus 4 is equal to 2x to the fourth minus 11x cubed plus 10x squared plus 12x minus 16. This is our the product written as a sum, okay? It's the sum of everything inside our boxes. This is our product written as a product. Okay, moving on. Now this is level 3. So let's start by filling in the boxes, and then we'll fill in the stuff on the right-hand side. So we've even shaken this up a little bit more. This time, I know only what my final sum is and what one part of my product is. I have to fill in the other part of the product. So to start the whole process, I remember that this top box here is my highest power. So that's going to be my 6x cubed. And then from that, I can say, well, what would I multiply 2x by to get 6x cubed? And that's going to be what goes along the top of my box. So that would be 3x squared. And then as soon as I know that dimension, now I can fill in the blue box here. So 3x squared times 5 is, I lost my blue, 15x squared. And then just like we did in the previous slide, we know that these two blue boxes end up adding up to 7x squared. So I've got to ask myself, what am I going to add to 15x squared to get 7x squared? Well, I actually have to take away 8x squared. And then I can start over. So I say, okay, well now I have 2x. 2x times something here is going to give me negative 8x squared. And I should be able to figure out that is negative 4x. Now that I know this dimension is 4x, I can do 4x times 5 to get my orange box here. So negative 4x times 5 is negative 20x. And then once again, I know these two boxes add up to give me negative 16x. So I ask myself, what would I add to negative 20x to get negative 16x? And I realize that would be 4. Now I have 2x here. 2x times something gives me 4x. Well, that's just 2. And now I know 2 times 5 will give me what goes in the green box, which is 10. And I see that that matches what I was supposed to have. So I filled in the generic rectangle. Now let's go ahead and fill in the statement here, okay? So complete the statement below. The statement below says, and let's compare where everything is here, 6x cubed plus 7x squared minus 16x plus 10. That's this. Divided by 2x plus 5. That's this. Is going to equal what? Well, before we do that, I think it might ask you to do this in the space above. Write this as a product. So what we're really doing is we're saying, let's take 2x plus 5, okay, and let's multiply that by 3x squared minus 4x plus 2. And when we do that, we get 6x cubed plus 7x squared minus 16x plus 10. Well, if you look at what we have in the next statement below, really what I did in this statement, I took this and divided by 2x plus 5. So really I just divided both sides by 2x plus 5, and that leaves me with just the 3x squared minus 4x plus 2. So really the big idea here is that we're finding a way to divide a polynomial by another polynomial to get the division here. All right, let's look at another one. Now, this is almost identical to the polynomial on the previous screen, but you're probably going to notice that the only difference is this is 18 right here. So let's see what that does to the process. So go ahead and fill in everything and come back and look at what you got. What you should notice is that when you start comparing everything, because all the way through this you're setting things up so that, this matches what you were given. You're setting it up so that these two, when you add them together, give you that. So that these two, when you add them together, give you that. But then you get to this last term, and you notice, hey, those aren't the same. We have 8 left over that we haven't accounted for. So we were able to divide, but it didn't come out nicely. So what you end up with is a remainder here. So really, if we were to say, our polynomial, let me write this here, 6x cubed plus 7x squared minus 16x plus 18, if we divide that by 2x plus 5, we get 3x squared minus 4x plus 2 with a remainder of 8. But here's the thing. I don't want to write it like that. When I write it, and I think there's an extra slide in here that I don't have, but you will have as you work through this. Instead of writing it with words, remainder 8, I'm going to write it like this. So I'm just going to put this out here, and you'll have a place to put this, I do believe, on your screen when you get to the slide that I am missing. So you have that polynomial divided by 2x plus 5. And like I said, we get 3x squared minus 4x plus 2. We want to write this with a remainder of 8 by saying plus our remainder, which is 8, over whatever we divided by. So that's the 2x plus 5. This thing right here represents your remainder. All right, and that's how we're going to write it. All right, go ahead and try this one. This is kind of like they call it the summit, level 4, highest level we're going to get to here, where you might possibly have a remainder. So go ahead and try this, and then come back and check your answer. And you should be able to check it as you go, but I'll just make sure, we kind of talk through how you would write it. Okay, take a second, check your work. You will notice how I wrote my answer in the box on the right-hand side with my remainder written as 4 over 3x plus 1. And a really easy way to figure out what your remainder is going to be is just to ask yourself, what do I add to 5 to get -1? Whatever this is represents your remainder, okay? Now at this point you can practice some more. They left you now a box for the remainder in case, you need it. But I'll let you guys practice this as many times as you need to feel like you're proficient. But I want to show you another strategy for how to actually divide polynomials, and it's using what we call synthetic division. All right, let's talk a little bit about this idea of synthetic division. A couple things about synthetic division that you need to know in order to use it. You can only use it when you're dividing by a linear polynomial. And what that means is 2 terms, right? And then highest power of 1. If you don't have that, you cannot use synthetic division easily. The second thing that's important to remember is that if you're missing any terms, for instance, if, say for this particular problem, I didn't have this 12x here, okay, so say my polynomial just went to -16, then I would have to put in a plus 0x here, because I need to make sure that I have, from where I start at an exponent of 4, that I see every exponent represented. All right, so I did have, I think it was 12x. We'll see in a minute. Yeah, I think that's right. So you have to make sure that every power is represented from your highest power down to your constant term. So you're going to want to place zeros to hold the place for any missing powers. Okay, now let's show how this is set up, okay? So the first thing I'm going to do is I'm going to take whatever it is that I am dividing by, so that x minus 4, and I'm going to set it equal to 0 and solve to get x equals 4. What I do with that is I place it in a little box all by itself. It's a special number, it gets its own special place. The rest of this we set up by taking the coefficients of each term in the polynomial that we're actually dividing. So what I've got then is 2, -11, 10, 12, and -16. And I'm just going to write those coefficients, 2, -11, 10, 12, and -16. I'm just going to write those coefficients. And then I leave a space, and I draw a line. Okay, so this can be a little bit quicker than using the box. And this is why I'm showing it to you, because it might be something that you want to try occasionally. What I do to start this whole process is I bring this 2 down below that line. And that's the beginning of this cycle, okay? Now the cycle starts by taking 2 and multiplying it by 4. So whatever we put below the line, we multiply by 4. 2 times 4, well, that ends up being 8. And then whatever I get here, I just add to that number above it. So negative 11 plus 8 gives me negative 3. And then I start the process again. So this time I take negative 3, multiply it by 4, and that's going to give me negative 12. And then I take 10 and add it to negative 12, and I get negative 2. And then I do the process again. So negative 2 times 4 is negative 8. Add 12 and negative 8, and I get 4. And then one more time. 4 times 4 gives me 16. Add negative 16 and 16, and I get 0. I'm going to put that in a different color, because this last number, whatever it ends up being, is your remainder. So if it's 0, that means there's no remainder, which is really nice. So let's figure out what we actually have here, okay? When we divide, we actually end up taking the highest power, whatever it was to start with, and reducing it by 1. So this is going to end up having a highest power of 1 less than 4. So that's x cubed. And then we just count down from there. So that's x squared. That's just x plus 4. So if we wanted to know what this is equal to, it's 2x cubed minus 3x squared minus 2x plus 4. So synthetic division can be pretty quick. The other thing that's important is what happens if we have a number in front of our linear term that we're dividing by. So we'll look at that on the next example. So, and I'm just doing examples from the Desmos so that you can kind of check to see that we do get the same thing. So if I'm going to divide these once again, I'm going to take the 2x plus 5, and I'm going to set it equal to 0 and solve, and you're going to get negative 5 halves. Now that negative 5 halves goes in the box. And then I take each of the constant terms, making sure I have all powers represented. So I see, and let's just look at that here. I see 3, 2, 1, constant. We're good. If I had any missing things, I would add a 0 in there to hold its place. So I'm just going to take each of those constants. So the constant for 6x cubed is 6. The coefficient. Coefficient for 7x squared is 7, and then negative 16, and then 10. Draw my line and start the whole process by bringing down that first number. So 6 gets brought down, and we start the process. So I'm going to take 6, multiply it by negative 5 halves. So that's going to be negative 30 divided by 2. That's negative 15. And then I add negative 15 and 7 to get negative 8. Take negative 8, multiply it by negative 5 halves. You're going to get positive 20. Add positive 20 and negative 16, you get 4. And then take forward, multiply it by negative 5 halves, and you're going to get negative 10. And then negative 10 plus 10 is 0, and that is your remainder. So again, we don't have a remainder, which is nice. Now here's the thing. Look, I can write this 6. That's going to be 6x squared. Since originally our polynomial had a highest power of 3, this is going to have a highest power of 2. Minus 8x plus 4. But here's the thing. And this is when your coefficient on x is not equal to 1 for whatever you're dividing by, okay? So when your coefficient for x is not equal to 1, You're going to look at your polynomial that you get. So look at this guy, and you're going to divide by whatever that number was. In other words, look for a greatest common factor. That has a greatest common factor of 2. I'm going to divide all of these by 2. So my actual answer for this problem ends up being 3x squared minus 4x plus 2. Right? It's whatever we get when we divide all of that by 2. And you can check this. This is one of the problems you did in the Desmos, just kind of to verify that that's actually the answer. So just to show you how you can use synthetic division if you choose. On the Go formative, I don't care which one you use. You could use either one, either the area model with a rectangle, or you can use synthetic division. But remember, synthetic division can only be used if you're dividing by a linear polynomial. So if you have something like you're dividing by x squared, you won't be able to use synthetic division for that. All right, good luck. You can go ahead and start working on the Go formative. If you have questions, you can leave them or talk to each other. I suggest trying to see if you can find some help from someone in the classroom, because I may not be able to reply to comments very quickly. And if you want to get your answers a little bit faster, see if someone in the room really understands what's happening, and maybe they can answer that question for you. Other than that, have a great day. I will see you soon. Be good for the sub.